Okay, guys, good to start with us. Are you back at the stations?
Yes, sir.
Okay.
Yes, sir.
So everybody has got 4.286, guys. Please confirm.
Yes, sir.
Okay. Now, firstly, we'll simplify this part. Which method are we using?
Lost point there.
Loss buoyancy
Lost
method.
buoyancy.
Okay. What was the buoyancy of the vessel in the intact condition in the rotational form? Look at the diagram of the intact condition.
LBD. LBD, sir.
Capital L, capital B, capital D. When will the volume of buoyancy change? Only if the displacement changes. Am I right? Correct? Buoyancy will change only if displacement changes. Am I right, guys? Volume of buoyancy. I'm not talking about how it is distributed, but how much did you regain? You regained what you lost. Am I right? Correct, beta?
Correct, sir.
Yes, sir. So basically, what will be the volume of buoyancy in this case? You can follow this. This is, of course, correct moment process. But you could, instead of it, cut short by replacing it by capital L into capital B into D, not D1. And if you calculate, you'll get the same answer here also. Why? Because you're using lost buoyancy method. Is that clear, beta?
Well copied.
Okay. Now, I'll just take a screenshot of it and go, because I have, in explanation, I have filled up more sheet here. So let me just take it to the next sheet. Okay, guys. So what you can do is, instead of LBD1 minus small LBD1, you can just straight away take LBD for the reasons I explained to you. Secondly, how will you make out that your KB is D1 by 2? How do you get volume of buoyancy? By integration of areas. By integration of areas. So guys, like I gave you the example of your notebook a while back. Look at this diagram, this one, upper one, and see, if you visualize the water plane area at half a meter drop, will it be like this? Yes. If you visualize at 2 meters, will it be like this? Yes. If you visualize at 4 meters, will it be like this in the bilge condition? Yes. Will it be same right from keel to W1, L1? Yes or no in the bilge condition? Correct, beta? Yes or no?
Yes,
Guys,
sir.
is in the bilge condition the water plane area from keel to W1, L1 same as we have drawn here? Or is it changing at any level? Tell me, is it same or is it changing anywhere? Bolo bhai?
It is same.
Same. So whenever the water plane area is same from keel to W1, L1 in the bilge condition, KB will always be D1 by 2. You don't have to waste time on calculation. What can you write? You can write like this. As the water plane in bilged condition is identical from keel to bilged waterline W1, L1, KB final will be equal to D1 by 2 equal to 4.286 meters. Have you understood in which condition will KB be D1 by 2, guys? Yes or no? We have also calculated. So whenever you have doubt, you can always go back to calculations. Nothing is stopping you from calculating. But if you're smart enough, you can save on time and then just one statement and you can get away. But every time this condition will not be satisfied. So if this condition is not satisfied, then you have no choice but to calculate by moments. Am I clear? And I have covered the calculation by moments here for this purpose only, that A, if you have doubts, B, if you can't figure out, and see if you can figure out and this concept does not apply, then in any case you'll have to use the concept of moments. Am I clear, beta? Class clear?
हाँ जी सर क्लियर.
Okay. Now we
Yes.
come to B. Now we come to BM. Though the water plane is drawn here, but I'll draw it here again slightly bigger because I have taken only a screenshot there. This is the water plane. I'm redrawing this diagram here, guys. This one is lost. This is 100 meters, 20 meters, 30 meters, 20 meters. Guys, for BMT, which axis do we need? You learned the other day.
Center line.
Not center line, forward and aft to
optics.
center of flotation.
Forward optics.
Through center of flotation. Okay, here, okay, it will be center line. That's a different issue, but don't blindly make it the center line always. Okay. In this case, it will be the center line. Why? Because you can see the water plane intact and lost is symmetrical about the center line. Correct? Here will be the center of flotation. Correct, guys? Am I right? Okay. So what will be BMT? BMT will be ICL of which area, guys? Look at the formula which we wrote first on the day of BML BMT. ICL of which area?
Area. Water plane area.
No, I didn't. First we wrote something else. Go back to the first formula you wrote.
Whole water plane
Intact
area.
water.
Intact water plane area.
Intact water plane
Intact
area.
water plane upon volume of displacement. Correct, Peter? Now, guys, when we did the COP of two shapes, what did we do? To get moment of inertia, we added I1 and I2. Yes or no? Correct?
Yes sir.
Same way, you can subtract the moment of inertia also. So instead of adding the moment of inertia of area 1 and area 2, I would prefer to continue with the same thing. ICL of the whole water plane minus what, guys? ICL of
Lost water.
lost water plane divided by volume. Write like this the way I'm writing. Now ask yourself a question. Is center line a standard axis for the whole water plane?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Can you give me the what will be the value of ICL whole water plane? What to multiply with what and divide? Can you tell me, guys?
Sir,
ICL whole water
100
plane. Tell
into
me.
20 cube by 12.
100 into 20 cube by 12 is this value. Is he right, guys? Yes or no?
Correct, sir. Correct.
Is center line a standard axis for the lost water plane also? Please look at the diagram and tell me.
Yes, sir.
So what will be this in the value form? Tell me.
30 into 20 cube.
30 to
30
20
into
cube
20 cube
By 12.
by 12.
What is the denominator V called? What is V called, guys, in the formula correctly? What is V called? Go to the
Bada L into
Volume of
Array, what is
displacement.
V called?
L into
What
B into D, sir.
Volume
is
of
V?
displacement.
What is V
Volume of
called?
the intact water plane.
100 into
एक minute, कुछ
volume.
भी बोलना. You are not listening to the question first. I am saying what is V called? Somebody is saying this, somebody is saying that. And
Underwater volume.
the last answer was beautiful. It is the volume of intact water plane. How can a water plane area have volume here? Kuch bhi, guys, if you speak like this, you'll
Volume
have
of
tough time in
displacement.
orals. You'll have tough
Underwater
time in
volume.
orals. No, I never
Underwater.
said it is underwater volume. Go back to the formula which you wrote when we did BMT and BML. You guys don't want to learn the correct things technically. What is V? Some people said correctly a while back. Some people in that entire confusion, some people spoke correctly.
Volume of displacement.
Volume of displacement. Yes or no? Correct?
Yes, sir. Volume of displacement.
My friend, if you start calling it underwater volume, you'll mess up this question nicely. Okay, because underwater volume is capital L into capital B into D1. Okay, so don't use wrong terminology. Guys, volume of displacement depends on what? It depends only on two things. One, displacement, two, density. Correct, beta? Yes or no? Volume of
Yes, sir.
displacement depends
Yes.
on displacement and density. Density is not changed. Has the displacement changed under lost buoyancy method?
No.
No, sir.
So what will be the volume of displacement? Capital L into capital B into small t. So it will be 100 into 20 into 6. Am I right? Yes or no?
Yes,
Correct,
sir.
guys? What is the volume of displacement of the intact ship? 100 into 20 into 6, right? And displacement has not changed. Correct, beta? Yes or
Yes,
no?
sir. Yes, sir.
And how much is the BMT you get then? If you have not understood, let me know. You see what
46
happens now?
points.
Sorry, say again, bete.
46.66, sir.
46 तो नहीं आएगा बेटे.
3.888.
Sorry, a minute.
889.
889. You have done something else, bete. Have you taken? I don't know what have you done. And now you have both KB and BM. You can add. So final GM will be equal to, or GM in the bench condition will be KB 4.86286 plus BM 3.889 minus kg under lost buoyancy method. One of the advantages was kg will remain unchanged. So minus 7.5, and it should give you an answer of 0.675 meters. Yes or no? Please see.
Yes, sir. Correct.
Okay. Guys, you have to use the correct terminology even when you're talking to yourself. That's very important. You can't conveniently change the terminology. And your basic problem with you guys is this only. That's why you're having tough time. You have not been learning the things the right way. I don't say that you are at fault. Maybe the system is also at fault. So I'm not fixing blame on you. But ultimately, it's you guys who are suffering. No? You end up suffering better. Guys, remember whatever we have learned in this question. I'll go to the second one. And now I'll prompt and you will tell me in the notational form. And whatever I prompt you to do, please do it. Even if it is wrong, you'll still learn. And if it is right, then fantastic. Yeah. Guys, in this case, will
Sir.
tell me. Yeah, tell me.
Sir, I understand what you were saying in this last question, and I totally get it. But Abhi, when I was going through the last steps, na, I had this one doubt, in which it is like I understand. Yeah, BMT is IW I by V is V. You say is volume of displacement, right? Abhi, what I did when you were prompted was uh, to calculate this volume of displacement because आपने बोला ना कि ये जो बिल्ज्ड एरिया है इट इज नाउ विद द सी राइट एंड इट इज
Yes,
नॉट एक्टिंग विद अस
correct.
मतलब ठीक है
Better.
तो व्हाट आई सर
Until
तो
go ahead,
ये
go
तो
ahead, go ahead.
हाँ
Hmm,
तो ये अंडर वाटर वॉल्यूम जब मैं कैलकुलेट कर रहा था ना सो
hmm.
आई व्हाट आई डिड वाज ये पूरा का जो वॉल्यूम है वाटर प्लेन एरिया का माइनस आई डिड
एक
दिस
मिनट एक मिनट एक मिनट वाटर प्लेन एरिया का वॉल्यूम मतलब क्या हुआ?
मतलब सॉरी नॉट ये गलत सॉरी सर ये गलत बोला मैंने ये पूरा जो स्ट्रक्चर है एल इंटू बी इंटू डी
Hmm,
लिया मैं कैपिटल एल इंटू कैपिटल
hmm,
बी
hmm.
इंटू डी ठीक है
Uh,
एंड आई माइनस इट विद ये जो
one second, one second. If you have taken D, then you have only taken this volume, na bete? This volume is the volume of displacement. If you're taking D,
आई मेंट डी वन सॉरी सर आई मेंट डी वन
then
क्योंकि
hmm.
बिकॉज वी आर कैलकुलेटिंग बीएमटी इन
uh,
द फाइनल
uh,
कंडीशन राइट तो देर
then go
इज
ahead. Go ahead, go ahead.
हाँ तो what I was thinking was कि because we are taking everything in the final for the
So what
final
did you know?
condition
You
only.
continue. What did you do after that? Let me keep hearing you.
हाँ
What did you do?
and then I subtracted this मतलब bilged
How
compartment
did
का
you
volume
how did you get the bilged one notational form? Please tell me.
L small l
Hmm.
into B into D1.
So beta, A while back, what did we do here? This and this we said, are both same. Yes or no? So why you want to waste your time? KB के डिनोमिनेटर में देखो हमने क्या किया था, कैपिटल L इंटू कैपिटल B इंटू D1 माइनस स्मॉल L इंटू स्मॉल B इंटू D1 किया था पहले.
Correct, sir. Correct.
और फिर मैंने क्या कहा था, दिस विल बी सेम एज LBD फॉर रीजंस आई गेव यू.
Yes, yes, yes.
So why you want to waste more time unless you have the luxury of time in the exam?
No, no, no. Okay, sir.
Unless
Okay,
the
understood.
examiner wants to give you half an hour extra, then it's okay.
Okay, okay. ठीक है, sir. ठीक है. Okay. Yeah. Bye.
This question has already been covered there, beta. जो तेरा doubt था. Anyway, guys, please focus here now. This intact condition is same. The answer is same. It's the same ship. Okay. Only thing is, what I've done is I have brought in DB here. So when it is intact, whether DB is there or not there doesn't matter. Ship is intact. Can you now make? We are doing part 2. Build condition straight away, guys. Can you make the side profile diagram of the ship? Draw the DB. Rest all notations mark as we have discussed. Don't deviate. And mark the height of DB as small h. The height of the DB you can mark as small h. Please make the side elevation diagram. First, make in the intact condition. Make the side elevation in the intact condition with DB. Please do that. Only stop at intact condition, guys. Then I'll draw and then you confirm whether your intact condition drawn is correct or not. Is this what you have drawn, guys? The side elevation in the intact condition?
Yes, sir.
Everybody has drawn or anybody is still drawing? Please speak up. Okay. Read the question and now shade off the lost buoyancy. Please shade off the lost buoyancy. Use your common sense, whatever your mind says. Don't worry. Read the question, shade off. So these are the steps you'll follow when you draw the diagram. I'm showing you the way, guys. Please shade the lost buoyancy. The bilging will be contained by the tank top, and this is the lost buoyancy. Is this what everybody has done?
Yes, sir.
Or anybody
Yes.
messed it up? Guys, if you messed it up, please own it. You'll learn it faster. Correct, guys? Okay, now this will lead to sinkage. Draw W1L1 and mark D1. W1L1, mark D1. Have you done that, guys? Yes or
Yes,
no?
sir. Yes, sir.
Okay. Everybody is done, guys. Anybody wants me to wait? My next question. Please look at the diagram. In the bilged compartment, will the water rise between W1, L1? Will it rise up to W1, L1?
No, sir.
No, sir.
No, sir.
So don't mark with the dots. Do not mark with the dots. Clear, beta? Previous question, it was rising up to W1, L1. We are marking it. Now do not mark it. Clear? So this diagram is complete. Below this, write down water plane area at W1, L1. Can you draw the whole water plane? And at W1, L1, shade off anything that you may have lost. Don't go by my statements, use your logic. Done, guys?
Anji, sir.
Any water plane is lost at W1, L1?
No, sir.
No.
No,
Everybody everybody agrees with him? Anybody in the class who does not agree with him, tell me. So water plane area at W1 L1 in the bilged condition will be this way. You'll see the whole water plane of length 100 meters, breadth 20 meters. You'll see these bulkheads, but there'll be no loss of water plane. There will be no loss. It will be fully intact. Correct, guys? Anybody in the class having doubts? Now, talk to yourself like this. I'm prompting you. Write down like this: sinkage, and you will write in the notational form. Lost buoyancy. Look at the upper diagram in the notational form. Put the lost buoyancy, notational form. And in the denominator, intact water plane from the lower diagram. And find out the sinkage. How much sinkage have you got? Tell me, guys.
0.6.
0.6. Is he right, guys? Dhruv says 0.6. Ali?
Yes, sir. 6.6, sir.
Ali, how much?
Sir, just one moment. A second.
Uh,
0.6, sir.
Sure? Okay. So guys, the upper diagram says small l into small b into h is the lost buoyancy. Lower diagram says the intact water plane is L into B. When you put these values, you get this one. Am I right, class? Then D1 will be equal to 6 meters plus 0.6, that is 6.600 meters. I'm sure everybody is good up to this place. Guys, now look at the upper diagram and see, is the water plane area same in the bilged condition from keel to W1L1, or is it changing at any level?
It is same, sir.
It is same in the bilged condition.
No, sir, it's not same.
Okay, so there is somebody who says it's not same. Now, what is your take?
Same.
Okay, can you? I'm not at. I've left the station. I'm walking while I'm talking to you. Who's that? Can you identify by name, beta? Who was that? Who said same? कौन था यार? मेरे को स्टेशन पे आने पे मजबूर. Ali, you said same, is it?
सर मैंने सेम बोला था पहले.
हाँ, अभी क्या हो गया? You change sides.
I agree. It will be the same. वो क्यों change होगा? It is not a curvilinear shape. It will be the same.
Okay, very good. In the bilge condition, what will be the water plane at 1 meter draft?
Water plane at 1 meter draft.
In the bilge condition, look at the diagram and tell me.
वो जो उसका वो हमें वाटर दिखने लगेगा सर.
नहीं तो
So we will have हाँ अगर 1 मीटर पे हम वाटर प्लेन लेंगे तो इट विल बी मतलब हमें वाटर दिखेगा. यही डायग्राम में फर्क आ जाएगा.
अरे यार, use the correct word. Will there be a lost water plane at 1 meter? Yes or no?
Yes sir.
Is there
At
a
1
loss of
meter it
water?
will be there.
Is there a loss of water plane at 3 meters?
No sir.
So is it
No,
same
sir.
from keel to? Is it same from keel to W1L1?
No sir.
So then why are you saying it's same?
Okay sir. Yeah okay sir.
So guys, in this case, KB will not be D1 by 2. You'll have to calculate by moments. Am I clear? In this case, KB will have to be calculated by moments. And now I'll prompt you and you write in the notational form, only the notational form. And please write with the class quickly. KB final. Your eye has to be on the upper diagram. Vertical moment of underwater volume up to W1L1. So first identify the volume up to W1L1, multiply by its vertical lever. Please put in notation form. Fatafat. 5 seconds down the line, I'll put it. And if you don't put, then you're not learning for sure. You are waiting for to copy from here, you'll never learn. The volume up to W1L1 underwater volume is LB. D1, lever is D1 by 2. Correct, guys? Yes or no? Correct? Yes
sir,
or
correct.
no?
Correct.
From here, we'll knock off the vertical moment of underwater volume. I'm not saying lost volume buoyancy. I'm saying underwater volume not contributing to buoyancy. Look at the diagram. Identify the volume in the notational form which is under the water W1L1 but not contributing to buoyancy. That volume is
Small L into
LBH.
small b into into h by
Yeah,
2.
identify its geometric center and see what
H
is
by
its
2.
distance from keel, h by 2. Divided by this minus this, but don't waste time, divided by LBD. Correct, beta? Yes or no?
Yes, sir.
We just discussed
3.53.
थर्ड डेसिमल प्लेस तक दे तो बेटा जो भी है कोई बात नहीं. This will be
3.530.
100 into 20 into 6.6. I write like this only because calculator has to do the job. Why should I waste my time in making them half or full? 20 into 2 into 2 by 2 upon 100 into 20 into 6. How much does it come? He says 3.530. Is that correct, guys?
Yes, sir. 3.530.
Now you can see this is not half of 6.6. Half of 6.6 would have been 3.3. Understood, class? So if it is not half, then you have no choice but to calculate. If it is half and you still want to calculate, that is your choice. But if it is not half, then you'll have to calculate. So you can't say, can I do without learning this concept of moments? No, you can't.
Sir, can
Guys,
you in
uh,
in an
tell
exam
me.
जब directly half आ रहा है, so do we have to mention anything or just directly write half of
जब
the
मैंने
top?
वहां एक इतनी बड़ी स्टेटमेंट लिखी थी प्रीवियस स्लाइड पे, तुम कहाँ गए थे? क्लास में नहीं थे क्या?
चल था
ऐ
सर मैं
क्या?
क्लास में.
नहीं, ऐ क्या तुम क्लास में ध्यान नहीं रखते हो क्या? ये क्या लिखा हुआ है इतना बड़ा बड़ा यहाँ पर? ये क्या लिखा हुआ है बेटा?
ठीक है सर, ये एग्जाम में लिखना. ठीक है सर,
नहीं तो
ओके.
तुम क्लास में रहते हो नहीं रहते हो केशव? मुझे नहीं समझ में आता तुम क्या करते हो भाई.
सर क्लास में था सर, मैं
तो
ये
ये
पूछ
कहाँ
रहा
गया
था सर,
फिर?
ये लिखना.
तो
ओके
मैं
सर,
फिर बेकार में लिख रहा था मजे के लिए?
ओके सर.
Okay, guys, KB is obtained. Now, whatever is the center of flotation will be the geometric center of the intact water plane. Can you mark the center of flotation? Center of flotation will be the geometric center of the intact water plane. Please mark the center of flotation. Draw 4.5 axis. Is that the center line? Yes or no? Yes or no, guys? Bolo bhai?
Yes, sir.
So draw the thing. So center of flotation is here. This is the 4.5 axis. This is center line. Calculate the BM beta. ICL of the intact water plane upon volume of displacement. Can you give me the value? Anybody who does not get, then we'll talk about
5.555, sir.
5.555. 555 or 556?
5.555, sir.
Okay, fine. 5.555 meters. Is it correct, guys? Just check. I don't think so. I don't think it is correct. Is it? Just check, guys.
So 5.556.
Okay. It's okay.
5.556.
Okay, fine. No problem. Then it's okay. Okay, guys. Now we are good to get the GM. GM will be equal to KB plus BM minus kg. And that answer should come 1.586 meters.
Yes, sir, correct.
Guys, what do you see in this question? If you see, in the previous question, the GM had reduced from the intact condition. GM had reduced. In this case, the GM has increased. Yes or no? Intact condition, GM was 1.055 meters,
Yes, sir.
and now the GM has increased. That's why, if you remember, when I was introducing the bilging, I said it will affect the stability. I did not commit myself to saying whether the stability will be increased or the stability will be decreased. I said it will alter the stability, right? Correct, guys? So I have done them back to back so that it does not send a wrong message to anybody that bilging will always reduce your GM. It is not necessary, beta. It is not necessary. Here the KB has gone up, BM has remained unchanged. That's why the GM has increased. Guys, anybody who's not comfortable with the process of calculating until this point, tell me.
So if GM has increased, that means the stability is getting better.
GM has increased, that's all. Stability better, but there will be trim also depending on location. It may cause adverse list, may not, you may not be happy with it. Only this is the GM increase. So one parameter has definitely increased, right? So as far as GM is concerned, GM is increased for sure.
Okay.
है ना?
हाँ जी.
See, I don't want to make any very express statements on overall stability of the ship. Overall stability is comprises of static stability, where GM or GZ is the criteria, including the transfer stability, where the list or the heel is the criteria, and the longitudinal stability, where the trim comes into picture. So you have to basically take a holistic view of stability. Yes, if you're talking of GM, GM is definitely increased. There cannot be two views on it, right?
Yes, sir. Okay.
Okay, guys. Now we can I go to the next question unless anybody has anything to clarify. So, guys, now will you be able to calculate KB if required by moments by talking to yourself, making those statements? Vertical moment of underwater volume up to W1L1 minus the vertical moment of the volume under the water not contributing to buoyancy divided by volume of buoyancy, which is LBD. So you should be able to calculate talking to yourself. Now we bring in the concept of what we call as permeability. Guys, both the questions that we have done, in these cases, the compartments were both empty. The compartments were empty. That means full space in the compartment was filled with seawater on bilging, or rather, full space was available for the water to occupy. But if your compartment that is bilged has some fitting fixtures, solid cargo in it, then obviously they will occupy some space. And when they occupy the space, now if you have the pipeline going through the tank, or you have some cargo which is lashed to the ship, so what happens? The volume available for the water to occupy will come down, will reduce, but the cargo or the equipment will remain rigidly connected to the ship. So whereas the water will not be the part of the ship under lost buoyancy method, the cargo and equipment which is rigidly connected to the ship's hull, they do remain and they do continue to remain part of the ship's weight and they contribute to the ship's stability whichever way they have to. So guys, if you have solid in the compartment, what does it do? It reduces the amount of space available for the water to occupy. Now, how do we represent how much space is available to us in the cargo compartment? That is expressed in terms of called as permeability. I'll come to these inherent things later. Permeability. What is permeability? It is the ratio of free space available for the water to occupy divided by the total space. So in a compartment, if the total space is 2000 cubic meter, then 1500 is occupied by the solid cargo or something. That means free space is 500. So 500 upon 2000 into 100 will be the permeability. Guys, because we'll not have the complete details in the question, I'm now talking only from the examination perspective. The solids in the compartment can be of different types. They may be homogeneously distributed in the compartment. They may be heterogeneously distributed. Somewhere you may have steel rolls, somewhere you may have cotton bales. They may not be homogeneous. Then they may not be occupying the full space. So maybe the height is less, not full height. Then some cargoes or some solids absorb water that can add to the nuisance. So what happens is, because if you want to talk of a specific case, then you have to provide a lot of details. And in questions, those details are not usually given. So when we solve these questions in the exam, we shall be working under certain assumptions. Okay. You don't have to write those assumptions. It's understood that you are working assuming the following things. So that you don't start asking me during the question, sir, what happens if the cargo absorbs water? Then if cargo absorbs water and you want my input, you have to give me complete details. Or if you say, sir, if the cargo is not from tank top to twin deck or up to the deck, then what happens? Then you have to give me the details. Okay. In the absence of details, we shall be working with certain inherent assumptions. And what are those inherent assumptions? Inherent or default assumptions for solving bilging of compartment carrying solid cargo. Cargo is filled in the complete compartment. That means top to bottom, port to starboard, forward to aft. Complete filling. Cargo is homogeneously distributed in the full compartment. Okay. Cargo remains secured in its location even after bilging. The cargo remains secured to the ship and no cargo is lost to sea. Because if tomorrow you say the bilging was so huge, some cargo is lost, so then you have to give those details from where it was lost, how much was lost. Cargo does not absorb water. Have you understood that these will be the unsaid assumptions under which we'll be working, and they make the things automatically, they make sense, because if you start adding these, then you have to provide more and more and more and more details to the person. Correct, beta? Clear, guys? Clear,
Yes.
class?
Yes,
Okay.
sir.
Now, to describe how much water can get into, we use the word permeability represented by small p. What is permeability? Permeability is the percentage of free space in a compartment available for water to occupy to the to the total space of the compartment. That is the permeability represented by small p. Now we'll take up questions involving permeability, and then I'll give you one homework. And if you can do the homework correctly, that means whatever we have done today, you have understood well. Okay, let's take a question. This is MMD exam. Which month? I am sure I have not written the month, but it is definitely MMD exam. So this will also give you some comfort that okay. A box-shaped vessel 40-meter long, 20-meter wide, 5-meter deep is floating in dock water of RD 1.005 with 3 meters even keel draft, kg 4.2. If a midship compartment 15-meter long extending from side to side with permeability 80% is bilged, calculate GM after bilging. Guys, now stepwise, please make the side elevation in the intact condition. Please do that. Whatever side elevation you made in the previous questions, make a similar side elevation, put all the measurements with notation. Fatafat, fatafat. Is this what you have made in the intact condition, guys? Yes or no? Correct? Is this what you have made, guys?
Yes, sir.
Now, when there is
Yes, sir.
cargo, how do you represent the cargo? You can represent the cargo like this. So please learn this now. And since I've already in our inherent assumption, we have said it is filling up the full car compartment, right? This represents the presence of cargo. And I can write down here permeability. It is 80% or 0.8. 80 upon 100 is 0.8, right? Now, having done this, can you please shade, in case this compartment is bilged, okay, length and breadth of this compartment, sorry. Length of the compartment, 15 meters, breadth is equal to 20 meters. Why? Because it says extending from side to side. Okay. Now in this diagram, can you please shade the lost buoyancy? Please shade the lost buoyancy, guys. Done? I'm sure you would have done this. Yes or no? Correct, Peter?
Yes, sir.
Yes, sir.
Very good. Now this will cause the vessel to sink. Mark the final water line and mark it as W1, L1 and the draft as D1. Then look at the diagram and tell me, will the water rise up to W1, L1, yes or no?
Yes, sir.
Then do the needful. Then do the needful if it is rising. Ali, Keshav, all good up to this place? So I put these dots here showing that the water will rise up to W1,
Yes, sir.
L1. Okay. Now guys, right below this, can you make the water plane in bilged condition? At which level? At draft W1, L1. Waterline W1, L1 or draft D1. You will see the whole water plane of length 40 meters, breadth 20 meters. You will see these bulkheads. Guys, when you cut it at W1, L1, will you see some surfaces of the cargo also there? Yes or no? Some surface at sea level will be occupied by cargo. Yes or no? Am I right?
Yes, sir.
Yes,
And
sir.
in between the pockets of cargo, you will also see the sea water. Correct, Vita? So, am I right? Anybody who does not agree with me, please clarify. Is that okay? Right, guys? Guys, in question number 1 and 2, we did where the cargo was empty, the tank was empty, compartment was empty. If I have to express in terms of permeability, what was the permeability in those two questions?
1.
1.
1 or 100%?
100%.
100% or 1, same, no problem. Good. Now, guys, see, sinkage. Sinkage is equal to, I'm talking to myself and you talk to yourself. Lost buoyancy. Now, lost buoyancy comes from the upper diagram. If there was no cargo, the lost buoyancy would have been LBD. Am I right, guys? If there was no cargo, correct? Now,
Correct.
80% of this space is available, not 100%. If 100% was available, this much is the buoyancy lost. But now only 80% of it is available for water to occupy. So that means buoyancy lost will also reduce in the same proportion. So I'll multiply it by P. My lost buoyancy will reduce in the same proportion as the permeability. Yes or no, beta? Earlier permeability was 100%. Full volume was buoyancy lost. Now only 20% is occupied by cargo. So what will I lose? The remaining 80% only? Because cargo remains part of the ship. Yes or no, beta? Am I right?
Yes,
Cargo
sir.
is not freely going to sea and coming back. It has not
Yes,
joined
sir.
hand. It has not betrayed the vessel. Correct?
Yeah, correct.
Divided by the intact water plane coming from the lower diagram. Whole water plane is L into B. Lost water plane, if there was no cargo, the full small l into small b would have been lost. But from this area, 20% is occupied by the cargo, and cargo belongs to the ship. So only 80% of this area is occupied by seawater. So the lost water plane is also reduced in the same proportion. Guys, before you put values only if you are convinced. If you're not convinced, first clarify with me and then put the values and find the sinkage. If you're convinced, then put the values and find sinkage, please.
1.286.
1.286. Is he right, guys? Is he correct, beta?
Yes, sir.
Yes, sir, correct.
1.286.
Sir,
Okay. Yeah, tell me.
सर डिनोमिनेटर वाला एल स्मॉल एल पी एंड परमेबिलिटी नहीं समझ में आया, ऊपर वाला तो समझ गया.
ऊपर वाले में क्या समझ गए बताओ?
मतलब सिंकेज में जब हमने सिंकेज कैलकुलेट की तो हमने जो अपना न्यूमरेटर है उसमें तो परमेबिलिटी डाली, दैट इज ओके.
नहीं, वो व्हाई दैट इज ओके?
सर बिकॉज वो कार्गो में अभी 0.8 ही स्पेस ऑक्यूपाई किया ना उसने, बाकी तो जो परमेबिलिटी और पानी आएगा उसमें वो ऑक्यूपाई
भाई
करेगा स्पेस.
कार्गो ने 20% स्पेस ऑक्यूपाई किया,
20%
परमेबिलिटी
ऑक्यूपाई की.
तो ये मत बोलो ना कार्गो ने 0.8 किया. कार्गो ने खाली 0.2 किया बेटा ऑक्यूपाई. डोंट चेंज द डेफिनेशन ऑफ परमेबिलिटी. Okay, in Simpson's rules, if you are getting volume, what were you integrating to get volume? Volume is integration of which thing? जब बुक की वॉल्यूम बन रही थी तो what were you adding together to get the volume of the book? Guys, volume you get by integrating what?
Area,
Volume
sir.
is
Area.
area.
Water plane area.
So my friend, if the volume is if there is a 20% of volume occupied by cargo, then at every area the cargo, because cargo is homogeneously distributed, ये क्या चीज है अक्षय? what are these things? ये what is this to you? ये एरिया
Cargo
क्या
है, sir.
चीज है? ये कार्गो किसको बिलोंग करता है? This area is the cargo. Cargo belongs to ship or sea?
तो शिप ही बिलोंग करता है सर.
तो शिप ही बिलोंग करता, तो ये एरिया किसको बिलोंग करेगा? जो मैंने सर्कल शेड किए हैं, ये एरिया किसको बिलोंग करेगा?
शिप को ही बिलोंग करता है.
तो शिप को बिलोंग करेगा तो इंटैक्ट नहीं होगा ये. विल दिस नॉट बी इंटैक्ट?
ठीक है सर.
See, now you'll see sense why I was saying whole minus lost. Otherwise, now you would have this area 1 intact, area 2 intact, and this one would have been another third area being intact partly. Instead of making A1 plus A2, A3, what we did was whole minus lost. So only 80% of the total area will be lost in the compartment, na? Akshay, yes or no?
हाँ सर, करेक्ट. ठीक है. Got it.
Okay, guys, that gives us D1. So D1 is 3 plus 1.286, 4.286 meters. Guys, look at the upper diagram and everybody to tell me, will KB be D1 by 2? Yes or no? Only yes or no.
Yes.
Yes.
There are a couple of yeses.
Yes.
Yes, sir.
Okay. Anybody in the class who feels KB is not half of D1, please tell me so that I can discuss with the concerned person directly. देखो, अगर एक बार मैंने KB की वैल्यू लिख दी और फिर पूछोगे, फिर मैं नहीं बताऊंगा, पहले बता दिया है. Then you start asking me and start pulling back, then I'm not going to get back. Okay, everybody says KB will be D1 by 2, so I'll not waste time in calculating by moments. Why should I waste my time? So what will I write? For benefit of Keshav, I'll write it again. As the water plane in bilged condition is identical from keel to bilged waterline W1 L1 AB in the final condition will be equal to D1 by 2 equal to 4.286 by 2 meters equal to 2.1843 meters. Is that 143 meters? Correct, guys? KB is 2.143 meters, right? Done? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, Akshay, you unmute yourself and tell me, where do you think, how many components of intact water plane area are there? Akshay, one, two, or three? How many components? Akshay,
हाँ जी सर.
how many components of intact water plane area are there in the lower diagram? One, two, three, how many? How many components of intact water plane are there in the diagram, beta? Water
Sir,
plane
two.
area. Which ones?
A1 and A2.
वो कार्गो का एरिया कहाँ गया? फिर वहीं पे गलती. अच्छा हुआ मैंने तुझे अनम्यूट करा लिया. Where does where does this area go? This is not intact. A while back you understood it and now you are back to square one. अभी 30 seconds back what did we discuss?
हाँ ये इंटैक्ट रहेगा.
नहीं तो अभी तो बताया था. क्या हो गया अभी इतनी देर में?
नहीं ठीक है सर.
So guys, you see, we know that BM in the final condition will be I about a 4.5 axis. So where will be the, see, you don't have to do all this. Where will be the geometric center of A1? Here. Where will the geometric center of A2? Here. Where will the geometric center of these intact planes? Here. Where will be the center of flotation? Center of flotation will be here, yeah, obviously. Why? Because when I draw a 4.5 axis through it, it's dividing the areas exactly into symmetrical mirror image on each side. Whatever is lost on one side, mirror image is lost on the other side. Whatever is intact on one side, mirror image is intact on the other side. Correct, beta? Yes or no? Am I right? Correct, class?
Correct.
Bolo
Yes, sir.
bhai? So
Yes,
BM,
yes.
so once you mark center line, now I can write ICL of the intact water plane divided by volume of displacement. Now there are three intact water plane. I don't want to make it I1 plus I2 plus I3. No, I'll make it simple. That's why we were talking about whole minus lost. Whole water plane minus ICL of the lost water plane upon volume of displacement. Guys, tell me in the notational form, not the values, notational form, what will be ICL of the whole water plane? Whole water plane about CL, moment of inertia. Tell me, guys.
Capital L into capital B का cube upon 12.
Okay, is it right, guys? Capital L
Yes,
into
yes.
B cube by 2.
Yes, sir.
Yes, sir.
Now, guys, if there was no cargo, if the compartment was empty, Akshay, if the compartment was empty, what will be the moment of inertia of the lost water plane about center line? If there was no cargo.
Small L into small B का cube by 12.
Okay, very good. But if there is cargo, then in the same ratio,
Permeability is
it will be lost. It will reduce, right?
Right, sir.
Correct. This is when the permeability was 1. If the permeability is 0.8, if permeability you put 1, it becomes LB cube by 12 when it is empty. If it is something else, then it is in the same ratio. It is the lost water plane is reduced in the same ratio. Correct, guys? Am I right?
Yes.
Yes or no?
Correct, sir. Correct.
Divided by volume of displacement. What is the volume of displacement in the lost buoyancy method, guys?
L into capital L into capital B into D.
Into D. And now it's only a matter of putting the values and getting the answers. Not 140, sorry. It's 40 into 20 cube by 12 minus 15 into 20 cube by 12 into 0.8 upon 40 into 20 into 3. And how much is the BM you get, beta?
7.777, sir.
777 or 888 or 778, whatever it is, जो भी है, ठीक है, देख लेना. Now you can add the two kb bm and subtract the given kg and see if the answer is matching. 5.721. 5.721 is the answer. If it's not matching, let me know.
It's matching. It's matching.
It's a MMD question. One of the, I've unfortunately not written the month, but it's definitely MMD question, guys. If you go through past papers, you'll come across this.
Sir,
Guys, have you हाँ बोलो, tell me.
sir, one doubt. Sir, in this question, this density is also given, so should we not multiply it with
Under lost buoyancy method, density has no role to play, beta. We are dealing with the volume, so density has no role to play, right?
Okay. So it is just given to confuse us.
No, if somebody wants to use added weight method, then density will become relevant, na beta?
Okay.
Because the displacement of the ship will depend on the density, right?
Correct.
I know. Under lost buoyancy method, it is irrelevant. So I would not say that it is to confuse, because somebody could be using added weight method also, right?
Right.
Okay. So that's why I would not say it is to confuse, but yes, for us it is irrelevant under lost buoyancy method. Okay.
Sir, in this question, we are on evil keel. Forward and out drafts are same.
अरे यार
Is
तू
there
पहले even keel master कर ले पहले बेटा.
नहीं सर, मैं ये पूछ रहा हूँ कि अगर क्वेश्चन में ऐसा हो सकता है कि
अरे
draft
तुम
से
यार
बाद
पहले मैंने चैप्टर खत्म कर दिया क्या बेटा? Have I finished
Okay.
chapter?
Okay, sir.
Okay. Guys, this is your homework question. I have given you the steps here. And if you do this question correctly, that means whatever we have discussed today, you have understood. I have given Sync separately. I have given KB separately. I have given BM separately. And of course, then the answer will automatically come. That is not an issue. I'm sending you the questions while you can have a look at the questions. That's not an issue. I'm sending you the questions. Give me a minute. Let me see if my WhatsApp is started getting it or not. Let me just see. Or it is still the same. Okay, stability. Okay, fine. Okay, which was the last question I had sent you guys from the prior learning? Let me just see. कौन सा क्वेश्चन भेजा था भाई लास्ट प्रायर लर्निंग का? वो भी भेज देता हूँ ना, तुम साथ लगे हाथ.
Question 5.
Question 5. 1 second. I had sent you November 19, then February 20, and April 21 तक आ गया था तुम्हारे पास. So 6 जाना है तुम्हें. Okay, so that's one question which goes to you. Then I have to send you the Bilging GM questions. Bilging trim hinship GM questions. Okay. This question number 1, 2, 3 we have done. 3 we have not done. 4th we have done. So we have done today, guys, this question, and this MMD question 5.721. This question number, this one I have given you as homework. This question also you can attempt. There is nothing in it. A box-shaped vessel 40 meter long, 8 meter wide, 6 meter deep. It's not the draft, it's depth. Read the questions carefully. Floats in sea water at an even keel draft of 3 meters. GM is so much. Guys, how does this question differ? Let me just see if it is there in the slides also. Or let me just take the question from here. If it's not in the slides, let me see if it is there. Okay, it's not there, is it? Okay, no problem. Okay. Questions. केशव मस्ट बी हैप्पी कि नीचे बिल्जिंग के आगे ट्रिम लिखा दिख रहा है इसको, है ना? कोई केशव खुश होगा ना? अभी तो एक उसमें लिख रहा है, दिखाओ। नहीं वहां पे तो असाइनमेंट स्क्रीन पे देखा होगा ना कि कुछ लिखा हुआ है वहां पे। मस्ट बी गिविंग यू लॉट ऑफ हैप्पीनेस कि मैंने देखो डाउट पूछा तो वो आगे एक टॉपिक में है। चल ठीक है भाई, जो तू जितना किया जाए पहले वो कर लो। सुनो, जितना किया जाए वो कर लो, एंड देन आफ्टर दैट ना, टुवर्ड्स द एंड ऑफ इट, इफ यू थिंक समथिंग इज नॉट डन, then you should break your head. First focus on what is covered, and then if after everything is covered and if you think something has been inadvertently missed out, nobody is stopping you from raising it. Guys, this question also you do. In this question, instead of giving the kg, he's given you gm in the intact condition. So what you'll have to do, you will have to calculate the km in the intact condition. You know how to calculate km, which will be equal to kb plus bm in the intact condition. Am I right, guys? Yes or no?
Yes.
From this, you will subtract the gm, and then that will give you the kg of the ship. And then you'll solve the question for Bilging. Is that clear, beta? Have you understood?
Yes, sir.
Yes, sir.
In all the three questions that we did, kg was given. Here what has he done? Instead of giving you kg, he's given you gm. So I would like you to do two questions from that assignment. Assignment is with you now. I would like you to do two questions. One is definitely one which will test whether you have understood what is being taught or not. First is in the middle row, the left question, and then in the lower row, so both the questions, the left ones, second and third row. The last two questions, we'll discuss them tomorrow. You don't have to do them today, okay? So don't worry. The same topic is going to continue tomorrow with some more tweaks and some more variations, okay? So it's not complete yet, the GM part. We'll finish it tomorrow, okay, beta?
Yes, sir.
Chalo. You do these two questions, and if you still have any doubts, please keep them ready for tomorrow. And see you tomorrow at 9:30, guys. Unless you have anything last minute, let me know, because then I would like to sign out from a physical class. All done?
Yes, sir.